Hello guys, welcome back. So in this particular video I'm going to be showing you guys how to handle standard forms, because it has occurred to us that most JAM students, science students, they really don't know how to work with standard form like addition, subtraction, multiplication and division. When it comes to standard form, they usually find it difficult because on the day of your exam as a JAM student, you will not have your calculator. It is not like WAEC that will allow you come into the exam hall with calculator. If it is JAM, you don't have a calculator. So you are going to solve without a calculator. So how do you actually handle calculations in standard form without calculator? That's what we are going to be doing right here. But before we go into that, first of all, let me teach you guys how you can convert um, numbers to standard form, and then how you can also do the reverse. That means converting numbers from standard form to normal decimal point expressions. All right, so let's take for instance I have something like let me say 0.02. Now this is a number. Now if I want to convert to standard form, what do I do? How do I convert this to standard form? Well, if you want to convert to standard form, you just have to shift this decimal point. Okay, this decimal point right here, you have to shift it. Now the direction you shift it to will tell how you are going to express it, how you are going to express the exponent. Okay, now if I'm going to shift this point, now I shift it from here, I shift it to this point, and then from here I shift it here. So that's me shifting it 2 times 1, 2. So at that point in time, it becomes, the point is no longer here, the point is no longer here, the point is now here. So it's now 2 point, let's say 0. Okay, then since I moved it twice, it's going to be exponential 10 raised to power 2. All right, now I have converted 0.2 to standard form. So 0.2 is the same thing as 2 times 10 raised to power minus 2, sorry, minus, because I'm actually moving to the right. Okay, whenever you are counting your decimal point to the right, the exponent will take a negative sign. Exponent here is this 10 raised to power, a value. Okay, it is called the exponent. So if you're actually moving your point to the right, it will take a negative sign. But if you're moving to the left, it will take a positive sign. All right, now take for instance this is 0.0001. Okay, now I am asked to convert this to standard form. What do I do? I'm going to keep shifting until I get to the front of this one. All right, so I'll shift 1 2 3 4. So this is now 1 times 10 raised to power minus 4. All right, so I've actually converted this to standard form. What if I have something like this? Let's say 5,000. 5,000 is the same thing as 5,000.0. Okay, it's still the same thing. So this is where the point actually is. Okay, so if this is 5,000, it means that the point is already at this part here. Okay, so if I want to convert this to standard form, I'm no longer counting the point today, I'm counting it now this way. So I'll move it from here 1 2 3, and I'll leave it there. So that becomes 5.0 times 10 raised to power 3. You can move it 3 times. No longer minus 3, but just 3 or plus 3. Okay, that's because I actually moved my decimal point from the right to the left. Okay, now whenever you are moving your decimal point towards the right, the exponent will take a negative sign. Okay, to take a negative sign. But if you are moving it to the left, it will take a positive sign, as in this case. All right, so now let's say for example you have let's say you have 100,000, and you have to convert this to standard form. What are you going to do? This is just 100,000, so you expect the point to be behind here. Okay, now move the point 1 2 3 4 5. 1.0. So 1.0 times 10 raised to power 5. Okay, sorry, raised to power 5. So it is just that simple and that easy. Alright, so this is how we convert to standard form when our value is not in standard form. Okay, and also if you want to do the reverse, it's also very, very possible. So take for instance, you have a case where you are given, let's say 2.4 times 10 raised to power minus 4, for instance. Now, how do you convert this from standard form to this kind of expression that is in decimal point? How are you going to convert it? How are you going to convert it to this kind of expression? So what are you going to do? Observe that the exponent is taking a negative sign. Okay, so the exponent is taking a negative sign, so you just bring out this part of it that is not the exponent, this 2.4. Just bring it out. Okay, and write 2.4. So what are you going to do? Since this exponent is a negative sign, you will count to the left. If it is a positive sign, you count to the right. So now let's count to the left and let's see what we are going to get. Okay, so I'm going to count to the left 4 times. So let me count 1 2 3 and 4. So the decimal points fell here. So right there, there's going to be 0, there's going to be a 0, there's going to be a 0, and of course in front of the decimal point you also have another 0. So this is actually 0.00024. Okay, so I've just converted it from decimal point. I'm sorry, from standard form to decimal point. Okay, now let me also convert it now from decimal point back to standard form. So I will still count it this way: 1, 2, 3, 4. 2.4. That's 2.4. Since I move 4 times 10 raised to the power minus 4. All right, it is that easy. And also, if for example you have a standard form, let's say let me use 2.1 times 10 raised to the power 5. Okay, this one now is not a negative sign. Okay, the exponent is a positive sign. So how do you actually convert this to decimal points? What are you going to do? You bring out this guy. Okay, just the 2.1. 2.1. All right, it is out now. So since the exponent takes the power of 5, we are going to move this point 5 times. This particular point here, we are going to move it 5 times to the right. Okay, so if you do that, it becomes 1, 2, 3, 4, 5. So the point is going to be here. So right here I'm going to put a 0, 0, 0 and 0. All right, you can still choose to put a 0 after decimal point, doesn't matter. All right, so this is now 210,000. Okay, 0.0, but that one is no longer needed. So at this point in time, you can see that this is 210,000. All right, so it is very, very easy to convert to standard form and also convert from standard form to normal decimal point. Okay, so at this point in time, I believe I have fully explained how you can convert standard form to decimal points and also convert your decimal points or your normal values back again to standard form. Now, having known this, I will now teach you how to multiply and divide in standard form. Alright guys, let me now show you how you can handle multiplication and division with respect to standard form. Okay, so now let's assume that we are faced with a question and I am forced to multiply. Let's say what will I use now? Okay, let me say 2 times 10 raised to the power 5. Then I'm multiplying this by, let's say, 3 times 10 raised to the power 6. Now this is a standard form, this is another standard form, so I'm going to multiply these two without a calculator. Okay, that's exactly what I'm going to do. Now whenever you are multiplying standard forms, this is what you do. You multiply this guy here, let me call it the base number. Okay, I'm not a mathematician, so I may not know what this is called in mathematics. All right, I may not know what it's called in mathematics, but let me assume it's a base number. I really don't know if it's called a base number, but I'm going to call it a base number here. Okay, so now this is the base, but I shall know that this is the exponent. All right, this is the exponent. Okay, so what you're going to do is that you're going to multiply the base and add the exponents. All right, so this is the base. 2 times 3 will give me 6, right? Yes, it will give me 6. Okay, so this is 10 raised to the power 5, this is 10 raised to the power 6. So what am I going to do from here? I'm going to pick one of the 10. Okay, times 10, then add the powers. 6 plus 5 will give me 11. So I have actually multiplied. This is my answer. Okay, yeah, very, very accurate. Now, let's assume you are faced with another question that says, let's say 2.5 times 10 raised to the power minus 19. Maybe you have to multiply by, let's say, 2 times 10 raised to the power 10. All right, now how do you multiply? Still the same method. We are going to multiply just the base. Okay, just the base. So 2.5 times 2 will give me 5. So that's 5 times 10. Now add the powers. This is minus 19, and on this other side is 10. Okay, so 10 plus minus 19, or rather minus 19 plus 10, that will give me minus 9. Okay, so this minus 9. Okay, very, very simple. So that's 5 times 10 raised to the power minus 9, or 5 exponential minus 9. So that's our answer. So that's just how you simply multiply when you have standard form. Okay, so let's take for example is something so complex. Let's say we are faced with a situation like let's say 10, no, let me use 10. Let's say 8 times 10 raised to the power 4, then times let's say 2 times 10 raised to the power minus 6, times let's say 4 times 10 raised to the power 8, then times, let's say, which will I use now? Let me say 2 times 10 raised to the power minus 5. Now this is a whole long stuff. Okay, and for someone who does not know the trick will think this is a huge problem, but it is not. Okay, this is just one standard form, another one here, and another one here. So what are we going to do at this point? We're still going to multiply all their bases and add all their powers. All right, so we'll start by multiplying this with this and this with this with this. Okay, so 8 times 2 will give me 16. All right, now 16 times 4 will give me 64. Okay, now 64 times 2 will give me 128. So I'm going to write 128 times 10. Now I'm going to add all their powers together. So this is 4, this is minus 6, this is 8, and this is minus 5. So let me add them up together. 4 plus minus 6 will give me minus 2. The minus 2 plus 8 will give me 6. Okay, minus 2 plus 8 will give me, minus 2 plus 8 will give me 6. And then 6 plus minus 5 will give me 1. So that's raised to power 1. Okay, so 128 times 10 to the power 1 is our answer. But it will not be sharp if you leave the answer like this. Okay, so 1.8, remember that from mathematics, anything raised to power 1 is still that same value. Okay, so 10 raised to power 1 is the same thing as 10. 5 raised to power 1 is the same as 5. Okay, so this is 128 times 10 to the power 1, that's 128 times 10. So you can even write the value as 128, that's times 10 will give you 1280. You can leave your answer like this, or if it is demanded that you leave your answer in terms of standard form, you still have no issue. What are you going to do? You know, this is 128, okay, times 10 raised to the power 1. This is what we got just now. So what are we going to do now? Remember that there's a point here. So I can shift the point here 1, shift it here 2. So it becomes 1.28. But because I shifted to this direction twice, this will increase from 1 to 2 and then to 3, because I shifted 1, 2. So that 1, 2 plus this additional one already here will now be 128 times 10 raised to the power 3. Alright, so this is the answer in standard form. Okay, the thing is, whenever you are shifting your points this way, if you keep shifting towards the left, any value on top of this 10 will keep increasing by 1. Will keep increasing by 1. But if the value here is a negative value, it will keep decreasing. It will still be increasing by 1. Okay, it is increasing by 1. Just that, you know, if we are working with a negative value, let's say we have minus 19 and let's say we have minus 5. Okay, if you ask someone who is not informed, they will tell you that minus 19 is bigger than minus 5. Okay, but meanwhile, minus 5 is bigger than minus 19. All right, so whenever you're working with a negative number, that's a number that has minus sign, the smaller the value, the bigger the number. Okay, so minus 1 is bigger than minus 50. All right, so minus 12 is bigger than minus 30, and minus 70 is smaller than minus 20. Okay, so as long as there's a minus sign, then you say minus sign attached to a number, the bigger that number here, the smaller the value. Okay, and the smaller the number, the bigger the value. So I expect minus 3 to be bigger than minus 10. Okay, and I expect minus 7 to be bigger than minus 14. Okay, so just take note, very important. So if, for instance, let's say I have a number like let me say 128 then times 10 raised to the power minus 8. Okay, so let's say I now move that point like this. Remember I told you that you're moving like this value will keep increasing. Okay, so let's say I now move like this and like this, become 1.28. I move twice, so this guy should increase 2 times. Okay, so times 10 raised to the power, where will I write? Should I write minus 10? No, remember that the smaller this value, the bigger it is. The smaller this number, the bigger it is. So for me to say, if I move like this negative sign is increasing. It means that we move from minus 8 to minus 7 to minus 6, because minus 6 is bigger than minus 7 and minus 7 is bigger than minus 8. Okay, so if I move like this, so I expect that this value should be increasing. Where should be increasing to? Is it from minus 8 to minus 9 to minus 10? No, that's not increasing, that's decreasing. Okay, so it will increase from minus 8 to minus 7 and then to minus 6. So what I'll put here is minus 6. Alright, so that is it. So at this point, if you observe this, our particular answer right here, this one, you see that what we actually got initially was this. Okay, so we have to shift the decimal point like this and like this. So when we did that, this 1 have to increase from 1 to 2 to 3. So we now have this as our final answer. So this is just simply how you multiply with standard form. Now let me teach you how to divide in standard form. Okay, we're going to look at how you can handle division in standard form. Now let me give one example. Okay, take for instance we are faced with 4 times 10 raised to the power minus 6 divided by 4 times 10 raised to the power, let's say 3. Now how do you do this division? This is a very simple division. Okay, you come across something like this while calculating. What are you going to do? All right, now look at this base. You divide this base. Remember that multiplication is the opposite of division, and division is the opposite of multiplication. Okay, so when we're talking about multiplication just now, we said that whenever you want to multiply, you multiply only the base and add the powers. So for division, you divide only the base and subtract the powers. Okay, so 4 divided by 4. What will that give me? To give me 1 times 10. Now, these are the powers. Okay, so I'm going to subtract minus 6 from 3. All right, now let me do that here. Minus 6 minus 3. This will give me minus 9. Okay, minus 6 minus 3 will give me minus 9. So this is 1 times 6 by minus 9. Very, very clean and correct. Okay, so now let's look at this other one. Let's say 2.4 times 10 raised to the power 8 divided by, let's say, 1.2 times 10 raised to the power minus 3. Now, how do you go about this? The same method. Divide the base and then subtract the powers. So 2.4 divided by 1.2. Of course, I expect that to give me exactly 2. Okay, expect that to give me exactly 2. So 2.4 divided by 1.2 should give me 2. Okay, I hope I'm correct. Now 2 times 10. Now subtract the powers. Okay, this is 8 and this is minus 3. So 8 minus 3. Minus times minus will give you plus. So that's 8 plus 3 to give me 11. So raised to the power 11. Okay, very, very easy and very, very simple. Okay, please take, whenever I see 2 minus sign, very close to each other like this, you convert it to plus. Okay, now let's look at another example. Let's say I am faced with 4.4 times 10 raised to the power 11 divided by, let's say, 2 times 10 raised to the power 6. Now how am I going to divide this thing now? Let's divide the base. 4.4 divided by 2, that will give me 2.2. So 2.2 times 10. Now you can see this one is 11, this one is 6. So what am I going to do? I'm going to subtract them. Okay, so that's 11 minus 6, that will give me 5. So raised to the power 5. That's simple. I'm done. Now let's handle a very complex situation. Let's say a situation this complex. Okay, this complex. Let's say I'm faced with 2 times 10 raised to the power 6 times 4 times 10 raised to the power minus 10. Then let's say divide by 2 times 10 raised to the power minus 4. Now you can see this one looks thick, but we'll still break it. Okay, we'll still break down the backbone and get the answer out. So what I'm going to do, you can see that in the numerator this is multiplication and the denominator is just 1 alone. So let's apply the rule for multiplication on top. What I'm going to do for this numerator, this is 2, this is 4. So multiply them, you get 8. Okay, 2 times 4 is 8. Then you add the powers. 6 plus minus 10 will give you minus 4. So everything on that numerator will now become 8 times 10 raised to the power minus 4. Okay, so 2 times 4, 8. This is 10 raised to the power 6, 10 raised to the power minus 10. So add them. 6 plus minus 10 will give you minus 4. Okay, you can always do that on your calculator or your jam calculator that will be given to you, or better still, you can do that with your head. This is 6 plus minus 10. Okay, plus times minus will give you minus. That's 6 minus 10. That will give you minus 4. All right. So divide by, this for the numerator. The numerator is this. Now divide by 2 times 10 raised to the power minus 4. So what are we going to do here? Okay, of course we are still going to divide the base and add the powers. 8 divided by 2, that will give me 4. Okay, times 10. Now subtract the powers. Okay, minus 4 minus minus 4. What would that give me? Remember that minus times minus will give me plus. So that's minus 4 plus 4. That's equals to 0. Okay, this is power 0. Alright, now this 4 times 10 power 0. And remember that for mathematics, anything raised to power 0 will give you 1. Okay, so this is actually equal to 4 times 1. Of course, that's equals to 4. So that's our answer here. Very, very simple and very, very easy. Now let's say for instance we are faced with another very complex situation. Let's make it even more complex. Okay, now let's say for instance we're having something like 2.5 times let's say 1.0, 2.5 times 10 raised to the power 8 times 1.0 times 10 raised to the power, let's say 7, and then times, let me use 2 times 10 raised to the power minus 6. Now divide everything by let's say 2 times 10 raised to the power minus 11 times 4 times 10 raised to the power minus 2. Now this is a very easy thing to handle. You won't even have to punch your calculator, though you may want to punch calculator in some aspects, but let's see if we need a calculator at the end of the day. Okay, because I know we are not likely going to need a calculator, and even though we're going to need a calculator, we're not going to be solving the standard form with the calculator. Maybe we're just going to punch maybe 1/2 or 2/5 or just something very simple on the calculator. All right, now let's handle the numerators first. This is 2.5, this is 1.0, and this is 2. So multiply all of them. 2.5 times 1 is 2.5 times 2 will give me 5. Okay, so that's 5 times, add their powers. 8 plus 7 is 15. 15 minus 6, okay, or plus minus 6, same thing as minus 6. That will give me 9. Okay, so this times 10 raised to the power 9. Divide by all this one under, do the same thing. 2 times 4 will give me 8. Then add their powers. Minus 11 plus minus 2 is the same thing as minus 11 minus 2. That will give me minus 13. So divide, this is 8 times, 10 raised to the power minus 13. Okay, now we are going to need a calculator here, okay, because now we are going to divide this base and then subtract the powers. So divide the base with your calculator, okay, and if you actually do that correctly, you should get 0.625, okay, then times 10. Now let's subtract these powers, okay. That's 9 minus 3. So let me do that here. Let's say 9 minus 3. This is minus and minus together, so that's 9 plus 3. That will give me 12. So I'm going to put the 12 here. Okay, now remember that whenever you're expressing your standard form, you see this value here. It must not be 0 point something. Okay, the value behind that, this is a decimal point. Okay, the value here must be greater than 0. It can be 1, it can be 2, it can be 3, it can be 4, it can be up to 9. Okay, it must not be greater than 9. It should never get to 10. Once it gets to 10, let's say you're having like 10 times 10 raised to the power 5. What do? You must shift the point from here to here. Since you are moved towards the left, you become 1.0. Then this 5 will increase to 6 times 10 raised to the power 6. Okay, that's what you do. All right. Now, at this point in time, we can see 0 here, which is not proper. So I'm going to shift this point this way so that everything becomes 6.25 times 10. Now, remember that I shifted towards the right. So if I do that, I expect that this value should decrease. Okay. Remember that when you are shifting towards the left, the number up here will be increasing, but if it is towards the right, it will be decreasing. So since I shifted once, this should decrease by 1 to 11. Okay, so this is now 6.25 times 10 to the power 11. So with that, I have explained how you can actually divide in standard form. All right, so I believe this video is helpful. So if you find it helpful, please do like this video, and if you are watching on TikTok, please follow this particular page, the Excellent Science Tutorial, and also if you're watching on YouTube, subscribe to the YouTube channel so that you get notified when we drop the next video. Okay, so thank you for watching. See you in the next video.